Hey guys, today we're going to have a look at Assessment 7. This is not a lesson, this is a practice test that was designed specifically for students who are preparing for the checkpoint exam. Now the topics chosen for this practice test were specifically inspired mainly from the 2016 Paper 2 exam. So if you want to have a look at that first, or you want to have a look at some of the lessons that we've been over, have a look at the links down in the description box below. If you feel prepared to go on, and this is your first time through this assessment, make sure you hit pause to try each question for yourself first, and then the answers will be taken up at the end. Let's get started. This first question is a proportion question. There are loads of proportion questions on this paper. This next one is for volumes of a cuboid. Here's another proportion question. A speed, distance, and time question. Simultaneous equations using the graph to solve. Again, another proportion question. The length of an arc and rearranging that formula. And areas of a circle. Now I'm really looking forward to taking this up with my group because they've done so well on this. It wasn't done by magic, we worked hard at this. So if you found those questions a bit challenging, have a look at the links down below, they will help. Now let's start taking this up. This first proportion question shows how x and y are proportional in this table. When we talk about proportionality, you need to remember, proportionality means that one value is some multiple of the other. Now I could have said that x is equal to some number times y, but I've written it this way because I can see that the y value is bigger than the x value. So it would make more sense for me to put it this way and work out hopefully some whole number for k rather than some fraction or decimal value. Now k can represent any value. It's called our constant of proportionality. So the first thing we're going to do here is work out what our constant of proportionality is so that we can work out a formula that links all y values with their corresponding x values. So given the x and y values that we know that y is equal to 64 when x is equal to 4. So I'll substitute that into my proportionality equation. Y is 64 and x is 4. So what is the constant of proportionality that we multiply by 4 to get an answer of 64? So we're going to rearrange this equation now to find out what k is. K is being multiplied by 4, so to get k on its own, we'll divide by 4. And 64 divided by 4 is 16. So our constant of proportionality is 16. Now be careful, that is not our answer for A or for B. It's just the value that we will use in our formula that links the values y with values of x. So setting up our formula for our proportionality then, y is always equal to 16 times x. So for A, for example, when we're given that y is 112 and x is equal to A, let's substitute that into our formula now to find out what A is. Y is 112, so 112 is equal to 16 times the x value. And here we're using A for the x value. So to find out what A is, just like we've done before, we'll rearrange this equation to get A on its own. A is being multiplied by 16, so we're going to move the 16 to the other side and divide by 16. So A is 112 divided by 16, which is 7. So we've got our first answer. A is equal to 7. For the second answer, we've already done all of the hard work over here, working out the formula for the proportionality between y and x. We know that y is always 16 times whatever x is. So for B, we're told that x is equal to 9.5. We need to work out what B is, which is the y value. So substituting into this formula then, when y is equal to b, so we'll put b there, x is equal to 9.5, so I'll put 9.5 there. B must be equal to 16 times 9.5. Makes sense, right? The y value is always 16 times the x value. So multiplying that out, b must be equal to 152. So we've got our answer for B, 152. Next question is about the volume of a cuboid. Now, this is a cuboid. It's not quite a cube because a cube would have equal sized and shaped faces on all sides. And this has got rectangular faces on all sides, and they're not all the same. So it's a rectangular prism, or a cuboid. Now, the volume for any type of prism is the area of the cross-section multiplied by the length of the prism. Let me show you an example. So if this was my prism, and again, it's a rectangular prism, I would label one of the faces the cross-sectional face. And I would call that my cross-section face because I know it's exactly the same shape and size as the face at the back. If I want to find the volume of this prism, I'll find the area of this face, and I will imagine that I'm filling this whole shape up with this face repeated over and over and over again until I get to the back. That's why I multiply this area by the length of the prism, as if I have that area repeatedly filling up the shape all the way to the other end of the prism. Now that is the formula for the volume of any type of prism. It doesn't have to be a rectangular face. It could be a triangular face, an octagon face, a heart-shaped face, any shaped face. If you're looking for more lessons on volumes of prisms, I'll link some down below for you. Now this is a rectangular prism. So the area of the cross-section multiplied by the length of the prism is the same thing as just the area of a rectangle, which we know is length times width, multiplied by the length of the prism. Now I don't want you to get hung up on this is the length and this is the width. So what is that? This is the length of the prism because it's the distance between the two cross-sectional faces. And for the area of a rectangle, we know it's length times width, even though looking at this shape, you might say that this is the length and this is the height. Don't get caught up on what's length, width, and length again. So what most of you would say the volume of a cuboid is length times width times height. And that's totally fine so long as you're just talking about cuboids or rectangular prisms. But I would like you to understand this theory about the volume of any prism. You never use this formula if it's not a rectangular prism. Okay, so now that we've got that clear, for this rectangular prism or this cuboid, we've got measurements in different units of measure. I've got this length in 1.2 meters, that's in meters. I've got this height, which is 45 centimeters. And I've got this width, which is in millimeters. Check what unit of measure you need your answer in. We need it in centimeters cubed, and start by working it in the right units of measure. So the 45 centimeters is fine. We'll need to convert the 1.2 meters and 380 millimeters. So there we go. Meters to centimeter, we times by 100. Millimeters to centimeter, we divide by 10. Now we're ready to use the formula, length times width times height, or this would be the area of the cross section. That would be the 120 times the 38, which is the area of the top rectangular face, multiplied by the length of the prism, in this case the height, the distance from that top rectangular face to the identical rectangular face at the bottom. So that's going to work out to be 189,000 centimeters cubed. Now, if you made a mistake and you didn't convert your units of measure correctly to begin with, it's very difficult to convert meters cubed to centimeters cubed or millimeters cubed to centimeters cubed. It's much easier to do it the way that we've just done. Let me just show you, for those who are interested, how we convert metric units of volume. If you've got a volume in centimeters cubed, most people make the mistake of thinking to convert from centimeters to meters, I just divide by 100. But to convert from centimeters cubed to meters cubed, we actually need to divide by 100 cubed because we're converting all three dimensions. So 189,000 centimeters cubed dividing by 100 cubed, that's dividing by 100 once, take off 2 zeros, divide by 100 again, so again another 2 place values along, and dividing by 100 again, another 2 place values along. I've moved all of my digits down 2 plus 2 plus 2, that's 6 places to put my decimal in front of the 1. Have a think about that before I explain how I would convert centimeters cubed to millimeters cubed. Usually to convert from centimeters to millimeters, we multiply by 10. But to convert from centimeters cubed to millimeters cubed, we will multiply by 10 cubed. That's multiplying by 10, so put on a 0. Multiplying by 10 again, so put on another 0. And multiplying by 10 again, so put on a third 0. Notice my answer is 189 million. I've put on 3 more zeros there. This might be worth checking out as well, so I'll link metric units of area and volume down in the description box below as well. Next question, again a proportion question. We're told that the value of A is directly proportional to the value of B. So once again, we know that one value is some multiple of the other value. And seeing that B is the bigger value, I'm going to say that B is some multiple of A. Now, seeing that B is some multiple of A, I hope it makes logical sense for you that if I made A bigger, B would get bigger. If I made A smaller, B would get smaller, because I'm multiplying a constant value by A, and if A is a bigger value, the result of this multiplication will get bigger. And if A is a smaller value, the result of this multiplication will be smaller. So when we're told down here, if A decreases from 6 to 1.5, A is getting smaller, so some multiple of A would also get smaller. So that means that B would also be decreasing. Now, how much it decreases, let's work that out. Given that B is equal to 10 when A is equal to 6, let's work out what K is, our constant of proportionality. Because once we've got that, we can work out the A or B values regardless of the value of the opposite one. So if A is 6 when B is 10, 10 will be equal to K times 6. I want to find out what K is, so I need to get the 6 to the other side. The opposite of multiply is divide, so I'll do 10 divided by 6. So K works out to be kind of a messy decimal value. 10 divided by 6 could simplify to 5 over 3 or 1.6 recurring. Now, as it's difficult to work with decimal values that are recurring like this, I'm going to keep using this top-heavy fraction, this 5 over 3. So I'll say that my formula, B is equal to 5/3 of A. Now, if we're told that A is decreasing from 6 down to 1.5, let's find out what B will be when A is equal to 1.5. So substitute 1.5 into our new formula here. B is equal to 5/3 of A's value, so 5/3 of 1.5. And just calculating that out, that's going to give you B is equal to 2.5. So I found my value for B. B is 2.5. There was an alternate method though. If you had noticed that A was divided by 4, 6 divided by 4 gives us 1.5, you would have probably also worked out that B was divided by 4 as well. So 10 divided by 4 is also 2.5. Either way you've done it, you'll have the correct answer. Oliver travels 240 kilometers and 3 20/60 of an hour. So I went easy on you with that one. I told you that 3 hours and 20 minutes could be written as 3 20/60 of an hour. Hopefully that conversion makes sense. Work out the average speed, giving your answer in kilometers per hour. So do not convert this 3 20/60 of an hour into minutes because we want our answer in kilometers per hour. So let's leave that as 3 20/60 of an hour. Hopefully by now you all know your speed, distance, time formulas. We use this triangle to remember them. If I want to know what the speed is, I see that distance is over time. Speed is equal to distance divided by time. Had I wanted to work out what the time was, I would see that distance is over speed, and I would say distance divided by speed. Had I wanted to work out what distance was, I would cover the d and I'd see that speed is next to time, and that you need to remember is multiply. We're working out the speed here, distance over time, given that the distance was 240 kilometers and the time was 3 and 20/60ths of an hour. We can just go ahead and do that division. So speed is equal to 240 over 3.3 recurring. Now, as we just said in the previous question, I don't really like working with these recurring decimals, and I think some of you might find it difficult to set that up. But 3 and 20/60ths of an hour is 3.3 recurring. So if you can put that on your calculator, you'll get your answer right away. But if you're having trouble with that, we can set this up simply as a division. This is 240 divided by 3 and 20/60ths. The 20/60ths does simplify quite nicely to 1/3. So this is 240 divided by 3 and 1/3. Dividing by a mixed number is not an easy thing to do. Let's convert this to a top-heavy fraction. 3 wholes is the same thing as 9/3. 9 divided by 3 gives me 3. So 3 wholes and 1/3 is the same thing as 9 plus 1 over 3. That's 240 divided by 10/3. And to divide by a fraction, again, you can calculate this on the calculator. But learning how to do this mentally, remember to divide by a fraction, we flip it and multiply. And to multiply by a fraction by a whole number, you only need to multiply that whole number to the top of the fraction. That's going to be 3 times 240 over 10, which is 720 over 10, which is 72. Now that's going to be 72 kilometers per hour, which you could have worked out from the very beginning. This is from a calculator paper anyways, but it is always a good idea to practice your mental calculations. Next, question 5. Use the graph to solve simultaneously these two equations. Now, we don't need to use too much algebra here. However, if we're going to use the graph, we want to know what the equation of the lines on the graph is. The equation of a line should really be in this format for us to be able to recognize it easily. Y equals some multiple of x plus, or if it's negative minus, some value. What we like about this formula is the number that multiplies by x is the gradient. I'm putting that in green for you so you can remember gradient. Now the letter m is just always the letter that we use. But if you need a reminder for it, you could maybe think of a mountain and the steepness of the mountain. The gradient is the steepness of a line. Plus b represents the y-intercept, and I'm putting that in yellow so that you remember y-intercept. Some people actually write that as y equals mx plus c, and c you can think of as the crossing point where it crosses the y-axis. So writing your equations of your lines in this format should make it easier for you to figure out which lines these are by seeing how steep they are and where they cross the y-axis. The first line, 60 minus y equals 2x. To get it into the correct format, I want the y on its own. So I'll start by moving the 60 to the other side. Be careful because the minus belongs to the y, not to the 60. So I still have minus y on the left-hand side, and on the right-hand side, my positive 60 became minus 60. Now it's not quite in the right format. I want the y completely on its own. I want it to be a positive y. So if I change the sign of the y from negative to positive, I'll change the sign of all terms. So on the other side, my positive 2x becomes negative 2x, and my negative 60 becomes positive 60. Now that it's in this format, I can clearly see that this line has a negative slope, the gradient is minus 2, and it has a y-intercept of 60. So I'm looking for a line over here that's sloping downwards, and these lines are all sloping downwards, and it crosses the y-axis at 60, so that's this one here. The next line, 2y plus x equals 60, needs to be arranged so I have y on its own. So I'll start by sending the x across. It was being plus, so I'll minus it. Then I want the y completely on its own. I need to get rid of the 2 that's out front. The 2 is multiplying by the y, so y on its own would be 60 minus x divided by 2. Both of these terms need to get divided by 2 so that I can see clearly y is equal to one term, which is some multiple of x, plus some other term, which is just a number term. So 60 divides by 2, and that gives me 30. And negative x divided by 2 would be negative a half x. So writing that in the correct order, y equals some number multiplied by x plus some number, I would have y equals negative a half x plus 30. So now I can clearly see that this line has a negative slope as well, however, not as steep as the previous one, with a y-intercept at 30. Looking over on my graph here, the y-intercept, this one's got a y-intercept of 50, this one's got a y-intercept of 30. It is a negative slope, but it is not as steep as this one, so that's going to be the line. Using the graph to simultaneously solve these two equations, which are shown as the red and blue lines on this graph, makes it easy because the one point that is on both lines, that is the x and y coordinate of that point, is where x is equal to 20 and where y is equal to 20. So my solution to this simultaneous equation is x equals 20 and y equals 20. Next, another proportion question. I'm told that 3 different people, Ina, Holly, and Miguel, all buy petrol and they all pay the same price per liter. But because Ina buys 12.5 liters, she pays 19.25 euros. Holly pays 27.72 euros, but I don't know how many liters she bought. And Miguel buys 17.2 liters, but we don't know how much he paid. We're trying to work out who buys more petrol, Holly or Miguel. So knowing that the price of the petrol and how much petrol we buy will proportionally affect the amount that we have to spend on the petrol, we can set up a proportionality equation for the amount of petrol and the total cost. Let me start by defining my variables. So I'm going to let P represent the amount of petrol that we buy in liters, and let C be the total cost of the petrol. So we can set up a proportionality equation where the cost is some multiple of the amount of petrol. So K really represents the price per liter of petrol in this case, because the total cost would be the price per liter multiplied by the number of liters we bought. Now we're told that Ina bought 12.5 liters, and we're told that she pays 19.25 euros. So if we substitute those values into this equation, we can work out what our constant of proportionality. Once we've got K, we actually worked out what the price per liter is. So substitute into that equation. I want to find out what K is, so I need to get K on its own. If it's being multiplied by 12.5, I'll take that to the other side and I'll divide by 12.5. Working out this division, that gives me 1.54. So our constant of proportionality, or our cost per liter, is 1.54. Now let's use that in the formula. So the cost of buying petrol is always going to be equal to 1.54 multiplied by the number of liters of petrol we buy. Let's use that on Holly's purchase. Given that Holly has paid 27 euros and 72 cents, let's substitute that into the formula to work out how many liters of petrol she bought. So 27.72 is equal to 1.54 multiplied by P, using a formula that we just worked out. And P on its own, we're going to need to get rid of the 1.54. It's multiplying, so we'll take it to the other side and do the opposite, we'll divide. That means that P must be equal to 18. Holly must have purchased 18 liters of petrol. Miguel purchased 17.2 liters of petrol. I could put this into the formula and work out how much he paid for it, but we don't need to do that. Reread the question before you go too far Who buys more petrol, Holly or Miguel? Holly bought 18 liters. Miguel bought 17.2 liters. So Holly bought more. Next question, arc lengths and rearranging the arc length formula. First of all, you need to remember that the length of an arc is some fraction of the full circumference. So our formula is some fraction, and that fraction depends on what angle we have between our two radii, and that's 48 degrees, over 360 degrees, which would be the full turn at the center of the circle, and multiplying by the circumference of a circle, which is 2 pi r. So substituting into that formula, if we know that the arc length is 16 pi and the angle between the radii is 48 degrees, that means that 16 pi is equal to 48 over 360 times 2 pi, and we need to figure out what r is. So we'll rearrange this equation. Now that fraction can first be simplified, so that's 2 over 15. And then I'm a bit intimidated as well by these pi's, but I see that I've got 16 pi on one side of the equation and 2 pi on the other side of the equation. If I want to get the r on its own and the 2 pi is multiplying by the r, I can take the 2 pi to the right hand side. I can take the 2 pi to the left hand side and divide by it. So 16 pi over 2 pi equals 2 over 15 times r. The nice thing about that is if I divide both top and bottom by pi, the pi's cancel out of this fraction. And even better, if I divide 16 pi by 2 pi, it gives me a nice rational whole number of 8. Now to get the r on its own, it was being multiplied by 2 over 15. So opposite of multiply, I'll divide it to the other side. And you can calculate this directly. However, if you like practicing your mental math, and I hope you do, remember that to divide by a fraction, we flip it and multiply. And when you multiply a whole number by a fraction, we only need to multiply the top. 8 times 15, that gives us 120, and 120 over 2 is 60. So the radius is 60 centimeters. Last question. Here we just need to work out the area of a circle when the radius is 14 centimeters. And give our answer correct to 3 significant figures. So we're going to need to round. Anytime we're working with pi, we're going to get a non-terminating decimal answer. So we'll always need to round. So first set up the equation. The area of a circle is pi r squared. Given that the radius is 14 centimeters, the area of the circle is pi times 14 squared. And 14 squared is 196. So this is 196 pi. That right there is an exact answer. As soon as I use the value of pi from my calculator, I'm going to get this irrational, non-terminating decimal number. And I'll need to round that. So 3 significant figures means 3 digits, the highest place value digits. And I've got 6, 1, 5 with a 7 after it's going to make that 5 round up. So that's going to be 616 centimeters squared. So that's it. I hope you found that this practice test and these explanations were helpful. If I've left anything at all unclear, feel free to leave me a comment. And like and subscribe if you want to see more practice tests like this as they come up.